Hello everyone, thank you very much for joining me again after quite a long time, but well, better late than never. Thank you very much for being here with me again. Today we are going to discuss about the JDK and the security APIs in the JDK, an important subject in my belief, and I hope that you will enjoy this discussion together with me. So I won't keep this very long. I'm just going to directly go to my screen here and we're gonna go through a few examples together. And of course, if you're watching this event live, I have a live chat there and I try to keep an eye on my live chat. So if you want to ask questions, please do ask questions in the live chat and start discussions, and let's make it fun. And if you are not watching this event live, where you can still put your questions and comments in the comment section, and we can discuss them later. I try to be as active as possible on my channel, of course. So let's get started with the security API. I think you all know that there is a security package in the JDK, so it's something like Java security, and then you have a lot of things here. You can see my IntelliJ suggesting me some of the most important classes and interfaces from this package. And an important thing to know about all this is that you can use them without any additional dependencies. So I have created in advance this Maven project, but it's just to save some time, and it doesn't contain any dependencies. So if you go to my POM.xml file, you'll see it's just a very simple example using Java 21, which happens to be the latest long-term supported version at the moment of this event, and that's it. So it's just a very simple plain project with the JDK. So whatever we write today, whatever example we create, only uses APIs in the JDK, and specifically here, of course, we talk about the Java security APIs. And I especially believe that it's essential to give this a little bit of attention, because I know that in many cases we give too much attention to different kinds of APIs in the JDK, like the collections API, like threads, streams API, date and time API, what else, you name it. Even reflection API. So I've seen that it's more likely that developers know how to use reflection, but they didn't necessarily touch too much, at least the security APIs. That's my point. So it's still something in the JDK itself, and if you want to be a real Java developer, then you have to be aware of all the specificities in this library that you are using. So let's start with a simple example. Generating random values. So we used to learn with books, and I'm talking here especially to maybe beginners with the language, and I'm pretty much sure I see from the comments that many of the people following me, and from the messages, of course, I get on LinkedIn and on Twitter. By the way, you can follow me there as well. Please follow me also on LinkedIn and Twitter, and let's chat if you have questions. I try to be active and of course spend as much time as possible with you. So from these questions I get and I discuss with my followers, I see that there are a lot of people starting with Java, and especially for those, for example, in books you find, for example, the use of math random. Even if you ask ChatGPT or an AI today, you might have a big chance to get a solution where math random is used to generate random values. And in some specific cases, people use the random class from Java util. So this is a comfortable way to generate different kinds of random values, and in the latest versions even get them as a stream. You have, for example, the doubles method that gives you a primitive stream of double stream type. You have the ints, which gives you a primitive stream of int type, and the long stream, the primitive streams are in stream, long stream, and double stream. So it facilitates a lot the generation of random values, but is it secure enough? Now, my recommendation is, if you want to have a real secure random value based on the entropy of the operating system, then what you want to use is the secure random class, which you have guessed is not part of Java util anymore. It's part of the Java security package. So the secure random is still very comfortable to use, but it does use behind the scenes the system's entropy, which makes the values much less predictable. Mathematically, I would say impossible to predict. So that's the point. So it's random, and then you can generate whatever you want. You can generate an int value, or if what you want to do is generating just a random string, what I usually do is I use this next bytes method. It's very easy, to use it. You provide an array of bytes of whatever, let's call it raw value, of whatever number of bytes you'd like to generate. So say I want to generate 100 bytes, then you generate the random values like this, next bytes. And then if you want it, for example, as a string, because you can't simply just print an array of bytes, you can simply transform any array of bytes in string just using a base 64 encoding, and be very careful. Base 64 is not an encryption, it's encoding, okay? So that's really important to remember. You can see that this is actually not even something from Java security, no. It's an utilitary class. Base 64 allows you to simply encode values from bytes to a string to facilitate the storage or the transmission, but it's no encryption and doesn't provide any kind of security. It's just a simple transformation. Remember that there is a big difference between encoding and encryption. The encryption is not any kind of encoding. An encoding is any mathematical transformation from a value to another, like in my case here, from a provided value as a row of an array of bytes to a string, that I can print in my console. So I can write something like this, and now I print that random value, whatever I have generated there, or I can store it, or I can send it somewhere much easily if I use it as a string. Cool. But again, the point for this example is, do remember this is my 100 bytes base 64 encoded, quite a long value. I should have chosen something like simpler, no? Anyway, so the point for this is secure random from the Java security package is part of security APIs, and it's what you want to use in case you want to generate hard to foresee random values. Okay, so choose this instead of the random class from Java util or from math random, of course, which is anyway something you probably would find not really comfortable to use in most of the situations. So I wouldn't expect that most of you in real world apps would actually use the math random, but I again talk here for all the new joiners to our Java world. You might be tempted to use the math random because it's probably the first way of generating random values that any beginner with Java learns. So that's why I'm talking about it. So let's call this example 1, because all the examples, like usual, they will go on my GitHub account, and I will put a link in the comments tipped on the beginning of the comment section, so you can find these examples. Okay, so example number 2, and what am I going to do with this? Let's go a little bit deeper. Hashing. So who knows what hashing is, what the hashing function is in cryptography? For those of you who don't remember or maybe never heard about it, when you discuss about hashing in cryptography, it means changing an input to an output using an algorithm in such a way in which changing the output to the input back is not possible. So there is one thing that you need to remember is that once we discuss about hashing, you say that you digest an input, transforming it into an output, such as the output. If you only have the output, you can never go back to the input. In fact, whatever you have, the output cannot turn back into the input. So that's a very important rule of the hashing function. There is a second very important rule as well, is that if you have the output and the input, you have to have a way in which you can match the values. So you can say, yes, that output has been created using that specific input. And that's why in most cases we use hashing to store passwords, because you have a way, you cannot, having the hashed password, this is the hash password, you can never get the real password. Say the 1, 2, 3, 4, 5 was the real password. Never use such a password in a real world scenario, no? But let's say 1, 2, 3, 4, 5 has been my password. This has been the hash output of a given function. I cannot decide, even if I know the algorithm that has been used and all the details about it and the output, I cannot find out which is the input. But if I get an input, if someone tells me, hey, it might have been 1, 2, 3, 4, 5, can you check if 1, 2, 3, 4, 5 is indeed the input for this? Then I can say it is or it isn't. So these two things, both of them need to be need to happen to have a real hashing function. So you need to have the possibility to know that the output has been generated by an input, but such in a way in which you cannot ever turn the output back into the input. Can we do that only with Java, only with the JDK, with now no other library and no other additional dependency in our POM.xml file or whatever you use, doesn't matter for managing your dependencies? Yes, we can. We can using this message digest class. This message digest class is a manager of digest algorithms, meaning hashing functions. So let's talk about the way you obtain such a manager of hashing functions in Java. First of all, the way it has been created back in the days, see, first of all, I'll bold it again, that's about Java security, okay, is that you can get a message digest object, such a manager named message digest, using the getInstanceFactory method, providing as a parameter, as a string, the algorithm that you want to use. So for example, here, you can say that I want to use MD5. Never use MD5 nowadays anymore, no, but it was quite a used hashing algorithms back in like 15 years ago, 20 years ago, I don't remember, okay? But you can still use it in Java. It's not recommended because it's very easy to find inputs using rainbow tables. But yeah, Java provides you with many algorithms, out of which even the oldest algorithms you can still use. So, for example, now I would actually go, for example, with SHA to an SHA 512, and I still need some to take care of something that is an exception that's called no such algorithms exception. So I want to give you a bit of an explanation about why getting this object looks like this, because if you are, maybe if you are a junior developer, if you are an entry-level developer, you might not figure out anything wrong with this code. You'd say, yeah, it's just a code. This is the way it's working. This is the way we use it. But if you are a more experienced intermediate upper level developer, you would probably say, hey, what is this doo-doo here? I mean, why should I first of all provide a string as a parameter, and can I just like put here something whatever I want, because it's a string, no? So I can simply use whatever string value I want, and what would that happen in that case? And secondly, why is this no such algorithm exception, a checked exception, forcing me to treat it and do something, whatever I want to do in the catch block? Well, these are two issues that remain as a legacy, but that's again because we discuss here about code that started to be implemented many years ago. So at that time, it was the best way in which this could have been implemented. So what happens is that if you try using here a value for which Java doesn't know how to use it, so let's say a non-existing algorithm, no? You use an algorithm that doesn't exist, whose implementation doesn't exist, then this no such algorithm exception will be thrown, and you have to provide whatever logic you want to provide if you want to instruct your application what to do in such a case. Normally this should not be the case. So maybe you wonder, okay, why don't we have a given value, some array of values, constants? Why don't we have enums? Why a string? Why a string and not an enum, or simply just why doesn't the JDK provides us with strings, specific constants with specific values that are supported? And the reason is, so behind the scenes we have security providers. So we have some objects that are used, and some of these are provided by the JDK directly, but JDK is made in such a way in which it is extensible, meaning that you can add your own providers, your own objects of that kind that might come with other algorithms that the JDK doesn't implement. It even allows you this way to implement somehow your own algorithm, but use it with the same set of APIs, decoupled. And that's where, for example, dependencies such as Bouncy Castle come in place. So we will not use any other dependency, because today's video is about everything that's provided by the JDK and just by the JDK, and I don't want to create confusion for any of you. But you will hear about Bouncy Castle, because most likely this is the most known dependency that augments with other algorithms the security APIs. And if you want something like whirlpool hashing, for example, or some exotic algorithm that the JDK doesn't provide, you have a chance to use it using the same APIs by adding and registering your own security provider. We will not do this in the specific video. Maybe I will do that somewhere in one of the next videos. But as a point of why is a string and not an enum is because, well, normally at the moment when this was created, there was no best way of doing it to have the possibility of having internal algorithms, but also algorithms that come from a library and you don't know what their name is, no? And what I would do now to implement it better, I would probably use a contract here. I would use an interface. But again, what we discuss here is code whose design started to be implemented many years ago, okay? I want you now to understand it as is, because when you will need to use it, you will have to use it as is. Okay, I talked a lot about it, but it was important because you will see the same pattern with all the next objects. I will not continue to spend the same time, of course, for each and every object that we will discuss further, but keep in mind the reason why this design was chosen like this, and we have this way strange maybe today way of dealing with this situation is what we just talked in the past 5-10 minutes. So what do I want to do here? I want to have, say, an input that I want to hash. This is your password. And then I want to digest your input, which will provide me a digested output. Something like that. The input cannot be a string, not that it cannot be a string, it can be anything. No, you can hash anything, not only a string. So in my case it's a string, but what I actually need to provide is the array of bytes for this specific string. Because normally you can even create a hash value of an image, no? You can hash anything that can be transformed into an array of bytes, and guess what? Any piece of data can be transformed in an array of bytes. In my case, it's a string. The easiest example I could give. So I get it as a bytes, I digest it, I get the digested version, and now pay attention to what I'm doing. So, because I'm gonna build somehow from the digested byte array, the string representation of this digested byte array, which will be actually my output. So I will have to go through the whole output. Digested. The output is the digested for me. I will go through the whole digested array and create the output. So normally what I can do to transform the byte back in something that I can put as a string and append it one by one would be to say integer 2-hex string of that specific digested of I. But if I do something like this, I will miss something important here, which is the fact that this one is not an int, it's a byte. And even though a byte can fit into an int, the difference between them at the memory level is that the int has 32 bits and the byte has only 8 bits. So the 24 bits missing, you have to fill them somehow with zeros. And to do that, the easiest way is to use a logic AND operation with the int of ff, meaning 255 in decimal, meaning 1111111, which will not affect, because you will have an AND with 1 will give you exactly what the value is, but will fill in the values, the zero values, transforming this byte into an int before trying to transform it using the integer class into a string. And that would give me an output. So this is, my friends, the way we can hash values. And I went up to the point where you got them as a string. And running this, I should basically get the SHA 512 encryption for this string of mine to be hashed. This was the second example, the third example. So let's go further. I'm going. I'm going further, discussing a bit about encryption. So again, we saw some example of encoding here, and I stressed out the fact that encoding and encrypting are not the same thing. And then you saw and you remembered or learned about hashing, which is a special kind of encoding. No, it's an encoding where you can get an output that cannot be turned back into the input, but you have a way in which you can test the output through the having the input. And now we really discuss about encryption. So there are two ways, two things I still want to discuss with you. One is the encryption, and the second one is the digital signature. And both these can be done using solely the JDK provided capabilities. Very important to remember. So you don't need something else. And if we talk about encryption, one of the ways to encrypt something is to have key pairs. Actually, the two ways in which you can encrypt something is either use asynchronous encryption, which ends up of needing key pairs, or symmetric key encryption, where you only need a key. We can demonstrate both of them. So let's say we start with asymmetric encryption, for which we need a key pair. Generating a key pair is again pretty easy with the capabilities provided by the security API. There is a class called key pair generator. This key pair generator class uses the same design as the message digest class that you have seen a little bit earlier. Remember the get instance, and you provide the string name of the algorithm, and then you have to treat the no such algorithm exception. Well, guess what? You have the exact same approach here. So you have to provide the algorithm you want to use. So for example, I might want to use RSA, which is probably one of the most known. And then of course I need to add a try catch for the no such algorithm exception. I will not discuss again this design because we have just discussed it earlier. The reasons why it looks like this are the same. So if you just joined, because I see the number of joiners to this live event is increasing. Hi everyone. If you just joined, we already discussed about this design that might look strange when we talked about the message digest class a little bit earlier, 15 minutes ago. Okay, just go back 15 minutes ago. And then you decide what is the size of this key. So you call the initialize method to decide the key size, and then you create a key pair, which is represented by this key pair interface, and you generate a key pair using the generate key pair method. So now you got the key pair, and from the key pair you can get the private key, and you can get the public key. And up to this point, we will talk about, as a next example, it's exactly the same thing you do when you want to use keys, asymmetric keys, for digitally signing pieces of data. So the first part, what we discuss here, is actually one capability of itself, because I talked about, we discussed encryption, but this first part of encryption, it's actually just generating the key pair. How to generate a key pair of a private and public key. This is something that asymmetric encryption or digital signatures, and I will show you how to do both of this. So if you decide to use it for encryption, then you remember that the private key is actually, you remember that the public key is used to encrypt, while the private key is used to decrypt. So unlike hashing, which we discussed in the second example, and we discussed that when you hash something, this value, there is no chance of turning it back to the input. So there is no chance of getting this and somehow being able to find out that this is the input that generated this value. When we talk about encryption, we talk about if you have something, you can find out the output. So someone would have to do the following: generate a key pair, and then the private key would be provided to the entity whom should be able to decrypt the value, while the public key should be given to anyone who wants to encrypt values and provide them to whoever has the private key and is able to decrypt them. So that's why further we will use the public key to encrypt and the private key to decrypt. And to do that, this is the second part of our example, is using the cipher class, which cipher class, guess what, is very similar to the key pair generator and very similar to the message digest class. Using the same design, the cipher class has a getInstance method where you provide the transformation, the encryption you want to apply to whatever value you want as a string. Again, the reason for this design is the same one we discussed on the message digest class a few minutes ago in this video. So in case you just joined, you might want to go back. So let's say I want to use an RSA ECB PKCS1 padding, which is one of the possible encryptions that you want. You'll see that here the exception that we need to add actually one more exception. You can either add it like that or put simply exception, whatever. Again, the design, the reason is the same design we discussed earlier a bit in this video. There are multiple ways in which you can provide this. So normally you provide the algorithm, the transformation, and the padding, but as far as I remember, and trust me, I don't know by heart all this, so I would have to like review them. But normally I think you could have just provided RSA case in which it would have went with a default for the others, or you can simply define them yourself. I always said put everything there in clear. One of my recommendations usually is put everything there in clear when you have to decide something. Because when you rely on defaults, you rely also on people knowing those defaults, which is risky because you don't know if people know which are the defaults or if they care enough to go and review which are the defaults. That's why as a developer, I try to be as much as possible explicit. One of the things you can compare with is, I was telling you in one of my JPA related videos, Spring Data related videos, that I always use the query annotation instead of relying on the method name, because that way I find it less risky when someone else will read my code on understanding that. Again, I deviated a little bit too much, so let's go further and say then we need to initialize the cipher, and because the same cipher is used for both encryption and decryption, then you need to provide, first of all, the algorithm, the operation itself. So this is a flag. The first parameter is a flag of the operation itself, and then of course you need to provide the key. Okay, and then we have another exception. So what I'm going to do, because I don't want to distract you with unnecessary things. I will just put the catch on exception here to allow you focus on what's important. So now I set the cipher on encrypt mode, and then what I can do with the cipher is, of course, encrypt. So I say, which is my value? Oh, didn't define a value. Let's say string value to be encrypted. Okay. Say do final, and of course you can encrypt anything. So that's why this method needs an array of bytes. You can provide an array of bytes of any kind of data you want to encrypt. Encryption is not only for strings, okay? For us, for making it simple, it's for strings, but normally it's not. So this is the encrypted. Now, unlike the hashed, the encrypted can be turned back into the value. Of course, you can now, it's an array of bytes. You can base 64 it and get a string, which is the encrypted. Now, you have the encrypted as bytes. There is a decrypt mode. But the decrypt mode needs to use the key that can be used for decryption. And remember, we discussed that anyone with the public key can encrypt, but only the entity, individual, whatever, having the private key can decrypt. So that's why when you set the cipher mode on decrypt, you need to specify the private key of the same key pair. It will only work with the private part key of the key pair whose public key has been used for encryption. And then the decrypted value is the cipher, do final, on the encrypted. And then if I write something like system out new string of decrypted, then normally this should be equal to this string in my case. No, I'm just turning back my value, my decrypted value, into the string so I can put it in the console. So running this normally should give me exactly this value that I have initially encrypted, and then from the encrypted I have decrypted. And look, here it is, exactly that value. Very easy. Okay, not gonna spend too much of your time. I want to show you example number 4. Which example number 4, I'm gonna do something that you should never do in real world apps. Don't do that. I will copy paste. Never do copy paste programming, trust me. But I will copy paste this time because the first part, which is generating the asymmetric key pair, is the same regardless on what exactly you want to do with the key pair. So it doesn't matter if what you do with the key pair is encryption or is signing. I want to sign data here. Digital signatures are used to ensure that a specific piece of data hasn't been changed when it is, for example, in transition. So what you do, you create a signature for it. And if, for example, when the signature and the data arrives, the signature doesn't correspond anymore to the data, then you know that the data has been altered. So it's an easy way to find out if some data has been changed in time. So if I want to sign this string, again, you can sign any piece of data. That's why, as you will see, it's still about byte arrays. So I will have to change this into a byte array. But I will use a string for simplicity. The difference is they are opposite. In this case, only someone can sign, but everyone can validate the signature. So to sign, you need to use the private key. And to validate the signature, you use the public key. So not everyone has the ability to sign a piece of data. Only the owner of the data can sign it, and then it can send the data. And anyone receiving the data might validate using the public key that the data has or not been altered. The difference is that unlike encryption, we will have to use, of course, a different manager, which of course uses the same design that we have discussed earlier at the beginning of this video. And to make it simple, it's called signature. Again, signature, get instance, provide the algorithm for the signature. Which might be SHA 256 with RSA, for example. Observe the same way, yeah, get instance and then string, yeah, string representing the algorithm that you use, which has to be a proper algorithm known either by the JDK or by any of the dependency you have used to enhance with other algorithms such as bouncy castle if you have added that. But again, today we'll talk about only about what the JDK knows. So throw new runtime exception just not to leave this cache empty. So we will call the init sign because we want to sign the data, and observe, to sign we need a private key, to verify we need a public key, no, exactly as I have written here up above. So we provide the private key because we want to sign, and then we sign the value, and of course you need to provide it as the bytes array. Okay, I think it's sign it without the parameter. You have to first update like that. Value, oh come on, get bytes, and then you get the bytes of the signature, something like that. And then you repeat the same steps if you want to validate the signature. But to validate the signature, you have to use the public key, because anyone should be able to, only someone should be able to sign, everyone should be able to validate. So then you can say init verify, because now we want to verify. Of course, we need to use the public key, so the pair of this private key. And then we update with value get bytes, and we verify the signature, which should provide us with a boolean telling us whether the signature is or not valid, which normally should be for us because we have nothing happened. We have used the same value here, so normally this should be a true in my console. So sorry, instead of valid I have printed the value. Valid is what I want to say. Okay, it's true, no? But if I would have updated here the signature with a different value, then this should be now false when I run it again. Here it is. Yeah, false, because definitely the signature has been created for a value, but I try to verify on some other value. So you see the signature, this way the signature can be used to verify the authenticity of a given value. And the last example for today, and then I'm out with what are the main capabilities of the JDK that you should know. It's still encryption, but this time I will try to use symmetric keys. So let's make this fifth example here. And in this fifth example, I'm gonna remember what I was using here. So I was generating a key pair, and once I have the key pair, I was using the cipher to encrypt and decrypt. I will still use the cipher, but instead of having a key pair, I will generate a symmetric key. To generate a symmetric key, you use something called key generator. So yeah, it's the same design as you have guessed. And because I'm not generating a key pair but a key, instead of naming it key pair generator, it is just key generator, and of course I have to use a proper algorithm that works for symmetric keys, which is, for example, AES. If you have a key generator, then you init with the key size, and then you can get a key which is called the secret key, and the secret key is the interface basically representing that unique symmetric key, and it's called a secret key because going back here, so here we have the private key is basically the secret key, but it's called a private key. The public key is not secret. Anyone can have the public key. That's why it's called a public. But in case of a symmetric encryption, there is no public or private. It's only one key, and because you use it for both operations, then it's secret. Only whoever has, because whoever has access to it can encrypt as well. Okay, so that's why normally there are less cases where you will find the symmetric key being used. It's simpler, but it has this false or flaws of not having the possibility to differentiate between who can encrypt and who cannot encrypt. But that's theory. Okay, so I want to show you some practice here. So this is my secret key from key generator. We generate the key. So see, you just make a comparison. Yeah, you generate this basically the same steps here, just that instead of generating a key pair, now we generate the key itself. And once you have the key, the things that you do are basically the same, so you can even copy paste it here. So you can, don't do that. Yeah, I know you might feel some pain when I'm talking about copy paste programming, but don't do that. It's not fair. Okay, and then of course the secret key here should be usable for both encryption and decryption of the value. Okay, and that basically should be it. And you can see, instead of using a private and the public, I'm just using only one key, the secret key, which is my symmetric key, and that's the way to implement with Java symmetric key encryption. Now, very important to know all these aspects, because you might be tempted to believe that these are complex things and that you need different dependencies and that you need to add things to your POM.xml file or whatever dependency management you use for things that might look simple, but in the end they are basic operations, and these basic operations can be done with the JDK and solely with the JDK without having any dependencies. So that was actually the purpose of today's video, and remember that I've managed to do it. In my POM.xml file there is no dependency. So everything that I managed to do today is just by simply using Java 21 in this case, which happens to be the latest long-term supported at this time. But you could have done the same things with Java 8. Of course, choosing a lower version of Java would impact also on what algorithms you might be able to use here. But these things are quite old, and as a Java developer, you should know about them. With that being said, I'm saying thank you very much again, everyone. Thank you for joining me today. I hope this talk was informative and hope to see you for another video. Waving goodbye. Cheers, everyone.